Hey everyone, and welcome. Today we're going to talk about a huge, almost invisible problem that's holding back scientific research. It's this idea that for every great discovery we read about, we're really only getting half the story. And of course, we're going to look at a pretty brilliant solution.
Think about that for a second. Every time a headline pops up about some new breakthrough, you're just seeing the summary, right? The conclusion. But what about all the data that got them there? Well, that's the other half of the story. And almost all the time, it's missing.
All right, so here's our game plan. First, we're going to unpack what this half-told story really means. Then, we'll ask a really powerful what-if question that kind of flips everything on its head. After that, we'll see how this tech DBbun makes research data native, check out its super clever business model, and finally, take a peek at what this means for the future of research itself.
Okay, let's dive into part one, the half-told story. And look, this isn't just some small inconvenience for academics. This is a massive, massive barrier to progress that, believe it or not, affects all of us. Every single year, millions of new studies come out. But the data, the actual foundation of all that work, is usually impossible to get. It's either kept private, it's locked behind all sorts of legal stuff, or sometimes it's literally just lost on some old hard drive somewhere. We get the final report, but we never get to see the actual evidence.
And this isn't just an abstract problem, This has real consequences. It's the PhD student who has to burn an entire year just rebuilding a dataset instead of pushing science forward. It's the AI startup that can't even check if its new model works against the published benchmarks. Or it's a government lab that can't compare 20 different studies on something critical, like climate change. It's like this huge hidden tax on innovation.
And that leads us to the big, transformative question. What if that just wasn't the case anymore? What if every single research paper, every single one, came with a data set that you could actually open up and use? So that question, well, it brings us straight to the solution. See, the answer isn't about forcing scientists to release all their private, sensitive data. It's about creating a whole new kind of data set from scratch. And here's the key idea. It's called a synthetic data set. Now, this is a data set that's generated automatically, just by analyzing the paper itself, the text, the tables, the charts. Here's the magic part. It never ever touches the original private data. Instead, it intelligently creates a brand new data set that just happens to behave statistically exactly like the real one would have.
And this slide just lays out the difference perfectly. The original data, it's locked away, it's often a mess, and it's a legal minefield. But DBbun's synthetic data is the complete opposite. It's totally accessible, it's clean and structured, it's free of any intellectual property issues, and you can start exploring it instantly. You get all the utility with absolutely none of the risk.
So how does this magic actually happen? Let's jump to section 3 and see how DBN makes research papers truly data native.
Okay, this is a really crucial point. DBbun isn't another website you have to remember to visit, or some new tool you have to download. It's infrastructure. It's designed to plug directly into the big academic publishers that everyone already uses, places like IEEE or Springer. It becomes a totally seamless part of the world that researchers already live in.
The whole process is actually pretty slick. First, the system ingests the paper. It reads all the text, tables, and figures. Then, it models the statistical structure. Basically, it learns the data's DNA. Next, the AI generates a brand new synthetic dataset that matches that model. After a quick, optional quality check, that dataset gets attached right to the publication's webpage, exactly where you'd hope to find it. And the core principles here are what make this whole thing work. It never needs the original data. It never even tries to reconstruct private information. So there are zero privacy issues, zero IP issues. It's just safe, totally automated, and built to handle millions of papers. Okay, so the tech is awesome, but who pays for it? That brings us to section 4, the business model. And honestly, it's just as innovative as the technology itself. This quote from the source material just says it all, doesn't it? DBbun isn't trying to sell datasets one by one to individual researchers. No, it's providing the underlying infrastructure, the pipes, that the publishers themselves, the record labels of the academic world, can build into their products to make them way more valuable. So see, DBbun isn't trying to create a whole new market. It simply adds a ton of value to the subscriptions that are already being sold to the big 3 buyers: universities, government agencies, and big R&D companies in pharma or AI. They're already paying for access. This just makes that access way more powerful. And here's what that looks like in the real world. An institution paying, say, around $32,000 a year for subscription might see a pretty modest price bump of a few $1,000s to get this data capability. It's a small increase for a massive new feature, and it fits right into the budgets they already have.
All right, let's zoom out for our final section and see how all this builds into something truly huge. This isn't just a product feature. We're talking about a fundamental change in how research gets done.
The market potential here is enormous. You start with a solid entry point in the US, and from there, there's a really clear path to a $100 million a year business across the globe. And long term, as this becomes the standard, that potential could easily hit $250 million annually.
And the best part is, the demand just naturally compounds over time. Every new paper that gets published adds more value to the network. Since it's baked into these big institutional subscriptions, it just renews automatically. And before you know it, being able to access the dataset will feel just as normal as clicking Download PDF.
So if there's one thing to take away, it's this journey. DBbun starts out as a premium feature, a nice to have, but it's designed to become absolutely essential. Indispensable infrastructure, just part of the basic fabric of scientific research.
And that leaves us with one final, pretty profound thought. Just imagine a world where this is the standard, where every new idea, every finding, every theory in a paper is no longer just text on a page, but it's something you can immediately play with, simulate, and build on top of. What really changes when every great idea becomes instantly testable?